one of the really important functions of kidneys is to regulate blood osmolarity. So even if you haven't had enough water to drink recently, you're still gonna be okay because the kidneys will help regulate that. So I have 3 different conditions up here. Normal conditions, if you're overhydrated, if you've had too much to drink, or if you're dehydrated, you have not had enough water to drink. So let's look at what happens to our cells and water movement under these 3 conditions. And this should actually be a little bit of a review from when we talked about osmosis earlier in the semester. So let's say we have a cell here. Okay, so the osmolarity inside of the cell is about 300 milliosmoles. Okay, and so there is blood everywhere, there's capillaries everywhere. So let's imagine that there's a capillary nearby. Okay, so this is our blood. Blood also typically has an osmolarity of about 300 milliosmoles. Right, and this is under normal conditions. So what's going to happen to water movement? Will we get water moving across that cell into the blood or the other direction or no movement? What do you guys think? So remember that water is going to follow its own concentration gradient from high water to low water, or in other words, from a dilute solution into a more concentrated solution. Both of these are the same concentration, but does that mean that there's no water movement at all? No, it does not. So we can assume that most cells are going to have aquaporins and water is going to be moving across the membrane. So there will actually be water going from that cell into the blood, but also just as much water going from the capillaries and into that cell. Right? It's in equilibrium, in other words. Okay, so that's normal conditions. What about a condition where you're overhydrated? So actually, let's draw the blood first. Okay, so you're overhydrated, the osmolarity is down. That means there's too much water, right? And not as much solute, so the osmolarity is decreased. Another way of saying this is that we have a hypoosmotic solution, right? So the blood is hypoosmotic. Okay, so what's going to happen with our cell? Which direction is water going to flow, right? You've had too much water to drink, and so there's a lot of water in that blood, and it's actually going to go into the cell, and the cell's going to kind of swell up, right? As all this water flows from this hypoosmotic blood into the cell. Right? If you want to put numbers to this, you can say, okay, the cell is starting at 300 again, and the blood is maybe at 100 milliosmolarity. Right? So definitely water is going to be going into that cell, and it's going to swell up. And this is actually one reason why overhydration is actually dangerous, just as dangerous as dehydration. So if you look at the module, there's a case study where there's a radio contest and they had to drink as much water as possible without urinating. And so that means that the kidneys are not able to help regulate the osmolarity, and their blood osmolarity just went down and down and down, and it caused cells to swell up. And in the case of one woman, it actually caused death because the brain cells were also swelling up, the neurons were swelling, that caused the brain to swell and press against the skull, and that can cause seizures or coma or, in her case, death. So just be careful about that as well. Under normal conditions, you're not going to be overhydrating yourself. The only time it's really happened to me was in a half marathon, and I wasn't doing a great job of like regulating how much I was drinking, and I drank a lot of water, and believe me, my body took care of that. So I was fine. You usually don't have to worry about this unless you're doing some sort of a contest or a competition or something like that. So just, yeah, don't overhydrate. Okay, so then the other one here is dehydration. So we'll put in our blood here. So in this case, there's not enough water. This is usually more likely to happen. Like you've been doing some activity and you just haven't been drinking enough water. You've spent all day hiking in the sun and you've been sweating and losing water, but you just didn't have anything to drink. So that can cause your osmolarity of your blood to increase. Okay, so this is now hyperosmotic. Okay, so what's going to happen to our cells in this case? Which direction is water going to flow? So it's going to flow from the cell, which is about 300 milliosmolarity, into the blood, which is maybe now 400, right? So it's going to follow the osmotic gradient, and that cell is going to lose its water, so it's going to shrink, right? As all that water flows from the cell into the blood. Okay, does that make sense? So that can also be dangerous as well, especially like your red blood cells won't be able to carry oxygen as well if they're all shrunk up. So both cases, not so good. And so that's why our kidneys are helping to regulate the blood osmolarity and regulate how much water is in the body. So let's look at how that works. So I'm going to add down here at the at the bottom, the kidney response. So what's the kidney going to do in each of these cases? So let's just say in the normal case, the kidney response is that you're going to make the normal amount of urine, whatever that means, normal amount, and the osmolarity of the urine is going to be normal. Okay, so normal urine osmolarity and volume. Okay, so we're going to measure the rest relative to that. So if you're overhydrated, what's going to happen to your urine output? Just think about it from experience. You've had a lot to drink. What happens to urine output? Volume increases, right? So you're going to get rid of that extra water. So urine volume increases. And in terms of the osmolarity, like the concentration of that urine is going to have a lot more water in it than usual. So the osmolarity goes down. It's dilute, right? So urine osmolarity goes down. One of the waste products that we get rid of is kind of a yellowish color. And so when you have a lot of urine that is low osmolarity, that yellowish color is going to get diluted out. And so this urine is going to look like more clear, less yellow, right? And the idea here is that you're trying to get rid of excessive water. So get rid of excess water. It's supposed to be an S there. Get rid of excess water. What about for dehydration? So how do we deal with that? Well, we want to hold on to the limited amount of water that we have. We don't want to lose it in urine. And so we're going to have decreased urine volume. And it's going to be more concentrated. Right? So it's going to have high urine osmolarity compared to normal. Okay, and that yellow color is still going to be in the urine, but now it's less dilute. And so this urine is going to look very dark yellow color. So if you ever see that, that means that you're dehydrated and you should have some water. And the idea here is that we're not adding more water to the body. The kidneys can't just magically make water, but we're at least holding on to the water that we have. Right, so yeah, so we can just say hold on to water in the body. We don't want to lose it in the urine. And then we'll learn later on that there's a signal that's released in this situation that will trigger your hypothalamus in your brain to make you feel thirsty. And then hopefully you'll listen to that and drink water, and then that will resolve this dehydration problem. Okay, so you can see that the kidneys, by regulating the volume of urine and how much water is in the urine, they can help regulate the osmolarity of the blood so that you're most of the time in this kind of normal range.